Perfect. So yeah, this project that I was reviewing a couple of days ago, the recap of what we've done. It was 2 years ago that we started with a bunch of engineers at Microsoft, and we clearly wanted to have some artifacts directly reusable for our customers' deployment, and having not only just recommendations, but directly reusable artifact. And it's all about it. If you look at the cloud adoption framework for Azure, that's really our one-stop shop where we are everybody, different entities of Microsoft come together to share entities, to share, recommendation around why you go cloud, how you go cloud, and in the ready stage, which is the one that we tend to focus as engineer, as architect. We were thinking like, hey, let's put a landing zone and let's put things that we can use directly here, and not just recommendation. And that's really all the journey that we've made. So of course you have all the recommendation on aka.ms slash CAF, but also you can see all the landing zone options that you have now. And our motto that I slightly inspired from Microsoft motto, which is empowering every SRE on the planet to achieve more. We have to have big and bold ambitions, but more seriously, one of the things that we're trying to do here is that, landing zone is cool, is usually the guardrails, the controls, the policies, the thing that we do. So this is right, this is nice. But what we were thinking at the beginning is like, since we're going to do this journey and we're going to put the DevOps mechanisms into our customers' environment, we're going to work on fancy standard mechanisms, different technology to deploy stuff. Why don't we take this advantage to enrich that with solution, and not only being happy to deploy log analytics to store my my log, storage account to store my long-term log, Sentinel to do the analysis and the CM capacity, but also how could we deploy very complex solution? Things that is, for instance, an app service environment with an app gateway. The app gateway is going to query a certification, a public certification authority to get a certificate, get the certificate, put it into Key Vault, and then dispatch it to the different applications. This is this kind of challenges that we were trying to resolve with our customers, and the kind of problem that we see Terraform super fit to resolve. And as that enable new ways of working, and new ways of working is basically for our customer, which is working differently, more DevOps, more collaboration between the teams. Because what we were seeing is really all the fancy DevOps activity happening on the let's say app dev team, but on the infra team we were seeing a little bit of lagging behind or lack of agility into some of the operations. So we wanted to see how we can move that and talk to the SRE audience and create the SRE capabilities on Azure, basically with Terraform. So that's a bit of the picture, and we can say it's been quite a journey. We've been really going through this journey of GitOps, even though we love to abuse this term, but really to use Git as an ultimate source of truth for an environment. And out of that, we did a lot of work on to the agnosticity that we could have towards the pipeline technology. I would say if customer wants to use Azure DevOps and GitHub, that's totally fine. If they want to use GitLab, if they want to use any other technology, if they want to use TFC into different variations and things that we can do with TFE, TFC, that should work. And really, this is a strong commitment and work that we had over the last years. And this is some of the things that we're going to discuss today. So that's the spirit. But when we're talking about landing zone at Microsoft, there is actually, if you look at it right now on the CAF page, two options. There is enterprise scale motion, and there's what we call start small motion, which ultimately, the idea is that enterprise scale brings first a reference architecture that we see here and a core of design concept and principles, and also an ARM template implementation with our first party tool. And in our team, we're working on implementing all the automation using Terraform and DevOps techniques. But if we look at the reference architecture and the reference model and how it looks like, really the idea is to have some kind of recommendation into different area, like the enterprise enrollment. How do we work on that? The management group. Here, how do we create the management group? What is a good grouping of a management group? Putting the policies that will then apply to the different subscription when you will put them into those management group to drive the behavior. So for instance, you see, you would have some corp landing zone. If I zoom on this one, then in this corp landing zone, probably I won't be able to create a public IP address. In the online, I will, and I will be able to create app gateway and all sort of techniques and product. So that's really this idea that we have those components, and then we have a set of core components like the identity subscription. So you can see that there's a large democratization of subscription in the enterprise scale reference architecture model, and scaling out based on subscription. So in terms of infrastructure as code, this is cool, and this is actually a lot of capabilities to deploy and a lot of things to deploy. So in the deployment options that we have and that we have done and we have worked, there's all kind of stuff. And usually on the Terraform side, we do start with the DevOps. So as you see here, the H side, when you see the DevOps and platform team, where we create the DevOps VNet, and we're going to talk into more details around that, around things to store the state. By default, in the vanilla option, we have this capability. But as I mentioned, if you want to use TFE, that's totally fine. And a set of pipelines that as well could be interchanged. And as well, one of the effort that we spend a lot of energy on is to have the capability to automate even the automation. So if you look at all of these components that I'm showing, it all starts with Terraform, with me locally on my console, or importing some of the stuff on my TFC or TFE. I bootstrap the creation of those components, and step by step, I'm going through the different layers and levels and create and compose a complex environment, which has all those elements, those management elements, but as well as we would call it, the landing zone subscription, which is a bit misleading term, but just to say this is the application subscription. This is where my workload will rely with my load balancers, my different VNets, etc., etc. So this is a little bit for the bigger picture and for what we can do. So that's the enterprise scale reference architecture, and this is our North Star when we're thinking about a good big environment on Microsoft Azure. Now, if we look a little bit at the components that we are leveraging to make that happen. So as we were discussing before, there's really a set of stuff that we put available. And I say set of stuff, let's do a quick overview of that. But ultimately, all of those stuff are absolutely open source. So there's nothing secret, there's nothing Microsoft not available, don't touch, don't look here. It's all on GitHub under MIT license. So you can have a look, you can improve it, submit issues, submit PR. And it's really something that we've seen happening quite early in the phases of the project. Actually, we had Microsoft people coming and contributing, but also customers and partners. And this is really something that was quite interesting to see. But ultimately, if we look at those components, what we have available is really one thing first, is a set of Terraform landing zone. Okay, cool. And actually, we have much less than before. When we started, we have landing zone for networking, landing zone for what we call foundations, landing zone for Launchpad, landing zone for whatsoever. What we really have done is a lot of simplification. Remember in the previous session, we're talking about don't repeat yourself. That's really what we've done. We realized that many landing zones were doing almost the same. So we consolidate those landing zones to do one landing zone for basically now what we have called CAF solution, and you can do everything from super complex networking stuff to app gateway to functions. That's the same landing zone. And this is all created by an underlying, the underlying module that we call the unified module. And also another guy that is the Terraform provider. And the provider was an interesting piece that we wrote, and it's serving one purpose right now, which is naming convention. And it might seem a little bit too much. It might seem, why do writing a provider for that? Is we tried to do it with a module first, and we seen it was really not super easy to manage the life cycle of the object. So we decided to go via a provider, and that really allows us to manage much better the life cycles of it. And it helps really in one particular phase, which is when you transition from the elaboration phases to the production phases. Because if you start to give names to your objects in the elaboration phases that looks too much like the production, you know the problem with the name that will conflict in names that must be unique, like in key vault or storage account. So with the provider, we just give actually a quick option to the landing zone to just say, hey, use the pass-through, means I'm going production, use the real names, or I'm inside the elaboration phase. So by default, you had a prefix and a suffix, depending on what you do. So if you have 10 engineers working and doing elaboration phases, then that's okay, because the names are randomized and they can validate their code into their side without caring about the name unicity and stuff. And there's another guy that we call the Rover that we have published, and we'll go into more details around that. But if we look at what's available, ultimately everything we published in the registry. So if I look for CAF in the Terraform registry, I'd be able to find the famous ASTF mode, which is the name that we give at the beginning and remain like that. But you can see that this module, the CAF unified module, since October has been used 118K. And the provider, if you look for Azure CAF, then you'll find the provider as well. And you see that's been used again a couple of times, and really when we instantiate that. So that's from the registry, but ultimately it all leads to GitHub, as we were mentioning, because that's a GitHub project. And if you see there, this is where we do the engineering. So we see we have the pull request coming, people opening issues, and there you have issues opened by customers, partners, and Microsoft guys. And one thing that also we wanted to have is the thing is the governance and the visibility of what's happening being in the open as well. So if you look at the GitHub project, you also have the public here project where you can see where we are into the phases, what is coming up into the April release here, where you see everything that is done, everything that is in review, and things that I need to check with the guys why it is not even started at more than mid-month. So this kind of thing, right? And then we have like the CAF Terraform landing zone repo, which is here the repo, as I was mentioning, where we have only the landing zone, so the launchpad and solution. And there's also another one, a third one, and I know it seems to be a lot of repo, but they all serve a different purpose. The module is the real logic. The landing zone is the assembly of the logic together. It's like a 3-tier architecture. And if you want, and if you see the starter is really resolving this problem, which is, hey, where do I start? Usually you say, okay, it's cool. So do I do monorepo, multi-repo? How do I put my environment? So here it's just, of course, an opinionated view on that, and say, okay, configuration, you have a demo environment. So this is how you start with your demo environment to spin up this environment with those instructions. So a configuration, let's say for my AKS service onto that, would look something like that, AKS TFVars, and here we'll see a little bit the syntax in a second. But that's overall the idea of those components being available and instantiable out of the registry, and really innovation happening in the open. One thing that we spend a lot of energy on, and is always a little bit misunderstood or a bit, let's say, difficult to apprehend at first, is what we call the Rover. So the Rover is actually two things. First is a Docker container, and second is a Terraform wrapper. And when we're using TFC or TFE, we can use either the Docker feature or both the Docker and Terraform feature. But ultimately, what we do with that is, very importantly, a consistent experience on Mac, PC, and Linux, because it contains a version toolset of what you need to run Landing Zone and Terraform. I think it's all clear to us now when we work in the team. It's hard to deal with different versions of the toolset, different versions of Terraform. And it's really important to make sure that when you are release a version of a configuration or an environment, you are sure that you are versioned. So I've developed code that is made to run under Terraform 14. So I'm sure that everybody runs Terraform 14, and there's not an auto update on my developer's laptop that has migrated me to Terraform 15 yet, because I will do the migration later. So this is what the Rover does. First, consistent toolset on all my developers, and also facilitates the transition to the CICD or to the pipeline. And what we mean by that is, as we mentioned, if you're using TFE, TFC, GitLab, GitHub, Azure DevOps, or any other CI, what we really wanted to is being able to completely move very easily from one environment to the other. And for that, we had a journey where we started with a full flat big Rover, and now we're running more on the concept that you see in TFC for business. You have this concept of runners and agents that really are mini Rover that we create that contains just the minimum to run and execute the operations for us. And it allows us also to work and code everywhere, including with GitHub Codespace. If we have time, I'll show a little bit of that in a minute. And I'll do a bit of demo of the Rover and why it's important in a second as well. Ultimately, the module as well is an important aspect. It's, as you see, we have spent a lot of work on consolidating the module. At the beginning, I think like many people, we were maintaining different small modules as part of CAF. And what we realized, it was created very little added value, and it was taking a lot of energy. And one of the things that we were not able to do in a good way is to test the integration of different components. And by that, I mean, create complicated stuff, complex stuff like I was mentioning before. So it could be a VM, which the password is stored in Key Vault, which the disks are encrypted using a customer managed key, which is inside a VNet with a private link being enabled, and all of this stuff. And really, what we wanted is to be able to be super fast into the composition of those complex environments. So it meant that the code was actually more complex to write. If you see, for example, an example of the logic of the module, you see that we are doing iteration on everything. So again, for each, and for each, which is try if we see something which is a VNet. If we don't, then just don't iterate. So then don't create any VNet. But then also when you go into this iteration, you'll find the VNet key. For instance, here's the resource group key to map back to which resource group is going to be this VNet location. And a couple of parameters like that, and it's even richer for virtual machine. You see that we integrate all different sort of parameters to be able to integrate that easily. So in the composition model, I have here my resource group key that maps back and said this VNet actually will be deployed into this resource group. So here, this is the key, region 1, the key region 2, and here we're linking this key to this key. So ABSG is the key for VNet. So if I declare 10 VNet, that's it. The module will iterate automatically for you. Now, why it's important? Because this module, we spend again a lot of energy to be able to consume it as a standalone stuff. So you can, ultimately what it means is you can prepare your environment as a standalone module, create 1 VM, 10 VM, integrated with App Gateway, integrated with all sorts of features, including the certification queries to some public certification authorities, and automatically test that on your laptop or run that totally independently on your TFC environment. And that's the first option, direct instantiation out of the registry. So if I go to my VS Code environment here, you see that I'm running a very simple code. It's on GitHub, and I'll give you the link if you want to play with it. But it's a very simple example where I just have a module example here. And when I run that, it's just here, you see I'm using all the arguments, but you don't have to. I can remove all the database stuff. I don't really need it. And here I have my configuration. And my configuration is super simple. It's just telling me, hey, create this resource group, create this VNet, and put it into this resource group. Create this public IP address, this key vault, put this key vault access policy. So it's all under declarative configuration. And it's all iterated by Terraform. And if you see virtual machine, now I'm doing the complex stuff. I'm saying, okay, store the password into KV1, create this VNet on this, create this NIC, sorry, on this VNet, those parameters for the virtual machine. And here, those are the source reference image, and the disk encryption set is here for my crypto parameters. And you see, if I do that, I can do Terraform on my laptop, right? And no, I don't. Remember, I was talking about the Rover previously. So just to give you a quick overview, if you are in VS Code, every time you put a folder called .dev container, I just copied it here. You see that actually it will declare that, hey, you're going to run an image here from this guy. So I'm going to project these files inside my Docker container. So now I'm opening my remote container. I'm downloading this version container locally on my laptop, and I will be able to run that inside my environment. So now I have Terraform. Now, why it's important? Because you see here, I'm going to test my thing running on Terraform 14. If I want to test the forward compatibility and I want to validate it's working on Terraform 15, I just need to put a rover that has Terraform 15, and I can just switch super easily like that. And I can do the same for checking if it works with Terraform 13. So that's a bit of the thing that we do for the local experience. And it's cool, but I would say it's not the only interesting thing that we're doing here. It's also, I'm going to push that to my VCS, and then the VCS is going to trigger TFC to pick up the module and run and do the plan. But importantly, before that happens, I also need to make sure that my code is correct. So what we do as well with the Rover inside our repositories is that we are including pre-commit as well. So by pre-commit, meaning that anything before the commit is even validated is going to be checked to see if it's compliant with what I want. So here you see that Rover has tfsec for me. So I can do here my command, I can initialize, and then I can run tfsec. But here I can also tell to my pre-commit, hey, anytime you have a push that you, a commit, sorry, that you have, then you're going to verify if it's compliant. There's no problem with tfsec, and the FMT is being executed, so your code is correct and it's not too bad. So this is for the local experience, and you see once I'm done with my changes, I can do my git push. And when I do my git push, I was mentioning before that we are consuming that out of the registry and using TFC. So if I'm going to my TFC environment here, you can see that I've created a registry demo. And here it's really picking up from this small registry demo 1 example that I created. It's just really a plan that I can queue manually here. And I will see that I'm just taking the code, so the module with the version I specified. It's going to run the variables, and it will then be able for me to execute and deploy the things on my machine. So needs confirmation. I have my runs going there. I probably can even confirm this one. I can do a confirm and apply. And the plan was finished, cost estimation finished, and apply queued. So in a couple of minutes, you'll see those guy things. So it means that again here, I've selected running on Terraform 15. We are running the module, and the module is also already realizing this complex composition that we were showing in the code, which is mapping all those objects together in order to apply the configuration. So ultimately, whether you're running a very simple example here, like creating a VM or creating 20 or 100 VM, it would be the same. It would be the same module, the same logic that would be executed. And as I mentioned, one of the things that we found is really super fast to compose an environment based on the declaration. And we really made an effort so that you don't even have to write code whenever you are doing composition within this module, and also outside of the module within the landing zone. So first way to consume the module via the landing zone, via the registry, a direct module consumption, sorry. Another one is to use it via a landing zone execution and composition model. So just want to show you the way we compose the environment, and this is more like a work in progress, but we have tested it, validated it, and we are now making it work at bigger scale. But ultimately, the idea is that we have created this hierarchy of different landing zones. And the idea is that each landing zone here would operate at a certain level, and this particular level will be having a set of landing zone that will be applied by a set of compute node. Now, what we have done for this particular model is the fact that a compute node is the guy that's going to basically execute the code. And as you mentioned here, in many of our customer environments, they say, well, you know what, I don't want to use public agents. I want to use my own worker agent, my own runners. So this is what we have worked on. And actually, the idea is that you have those compute nodes, they sit within your virtual network. VPC, if you're familiar with the AWS world, then that's the same idea. So it's isolated inside my virtual network. And it's important because then it has access to the workload that otherwise I don't have access with the public IP. And what's important as well is that those compute nodes, they authenticate against the Azure infrastructure. So what I mean is when I'm giving my authorization to my environment, I'm not getting authorization to service principals. You know, the problem with service principal, you have to manage their lifecycle, but we're using that with Azure Managed Identity. So it means that we're using the compute node identity to authenticate, and then this is how we authenticate against the subscription. And the authorization is same thing, described by our configuration format. And you see that I put compute node here. I didn't put VM or containers because actually it could be both. It could be a VM using an MSI that is enforcing the configuration, or it could be containers running into ACI, Azure Container Instances, or it can also be containers running inside an AKS cluster with different pod identities to impersonate those different levels of managed identity. And then we can play with the scale up of the container instances within the pod. So that's a bit of the idea. So there's many stuff on this slide, I know, but ultimately the idea is that within what particular level you would have one or many landing zones. So for instance, in level 0, you will find the DevOps fundamentals that I was mentioning, like the virtual machine or the container instances. And inside the higher, and inside level 0, sorry, before that, you will also have all the subscription, creation, delegation, landing zones. So creating, whether you have an EA or MCA, you delegate that. And in level 1, this is actually where we will fit most of the enterprise scale component, because enterprise scale, we do a lot of management group, a lot of policies. So in a level 1 landing zone, we call the enterprise scale module that will deploy all this structure for me. But the story continues because at level 2, we then spin up the networking stack with Terraform native module. Then at level 3, we put our AKS cluster, app service environment, etc. And at level 4, we put this application more description landing zone. So really the idea is that all of that is done by reading a state up and down, and reading this state able to compose an environment. So doing complex stuff, but enriching from what others has been done. And if you see, the lower level represents, if we compare to operating system, more the kernel mode, and the higher level represents more the apps part. And as I was mentioning, this is leveraging the compute node, leveraging the TFC agent pool part. So remember, if we try to link that to our TFC environment, when you create a new workspace, you can do a version control workflow, which is the one that we know most. We can have the CLI-driven workflow on which I can use to store my state, for instance, remotely. And here there's also the API-driven workflow that I can use, and that could be a model where I integrate the most complex environment. But if we go back as well to my previous workspace in a very simple way, remember when you're going here to the way you're running this workspace, you can do a remote run, you can do a local run, or you can do an agent run. And this is really what we're talking about here. We're talking about having my agent pool. So here, this is a VM or a set of VM running inside my virtual network, my Azure environment. And this means that if I select that, if I save that, then when this workflow will run, it will run with this particular compute host inside my VM. So then it means that I'm able to leverage the MI features and all those things I was mentioning before. So here we have done a proof of concept of that, and we are working on the industrialization of that. Same thing, to be able to leverage completely this capability. And also on the landing zone composition across the different layers, this is the responsibility of the landing zone to show you how to read from one level up and down. So this is really the idea of that by default, we're able to realize that on the storage account for Azure, but we can also do that perfectly and super easily based on Terraform Cloud and Terraform Enterprise. So same thing on that, we have completed the proof of concept and make it work in a couple of customer environment. Now we're working on industrializing the code, sorry, to make that work transparently. So read the state one level down transparently. You just say, I want to do that on Azure Storage Account, or I want to do that on TFC cross-state reading with the data source. So that's really the way we are operating here. It's taking a little bit of time, but I show you a little bit the idea that we want to have here. And overall, the idea is that what matters is learning, creating, composing stuff. So basically start with the module, deploy things everywhere, TFE locally inside Rover, inside GitHub Action. Take that into the landing zone field if you are ready to do so. If you want to use the enterprise composition, totally fine. If not, then we're fine with that as well. And ultimately, the idea is that you can do contribution to all of that. And really, I insist, this is really the way we are driven. Opening PR, opening issues on GitHub. That's really something that that we're delighted to see every time. Chatting on Gitter, we have guys in the team monitoring that as well. And ultimately, aka.ms/tf landing zone. That's really where we see the code, where we publish the stuff, and where we answer to the questions and interaction.